everyone. We're going to start with section 4.3 with the coefficient of determination, and you just need to remember your section 4.2 and what you learned how to do in your calculator, and you should be pretty fine in this section as well. So first of all, what's the purpose of a regression equation? Well, it's a trend line. We use it to make predictions, but I can make any prediction on any equation. The question is, I need to make sure that equation is useful. Is it valuable? Is it an accurate prediction? And that sort of thing. Okay? So the coefficient of determination is r squared, and what it is the statistical definition is that it's the proportion of variation in the observed values of the response variable explained by regression. So it's the variation in that observed and that we're getting from the regression line. In English, it just means how useful is the regression equation for making prediction. Is it close or is it not? Now, r squared will always be between 0 and 1. 0 tells us that it's not very useful, you might as well chunk it. Okay? 1 says, alright, you better go ahead and use that. You're good as gold. Okay? So, the closer you are to 1, the better. Now, if you're going through your book, you're going to see something called the sum of squares of regression. And SST, SSR, and SSE. SST, excuse me, is the total sum of squares. That's the total variation in the observed values of the response variable. Now there's a big long equation for you finding that. Don't worry about that so much. This is a little outdated in application, so we're not going to spend very long on it. If we do anything with SST, SSR, and SSE, you will be given those values and asked to find other things based on the two equations we're going to go over on the screen here in just a moment. But most all of the coefficient of determination problems we're going to use our calculator to solve. Okay, as I showed you last section. But the regression sum of squares is the variation in the observed values of the response variable explained by regression, and the error sum of squares is the variation in the observed values of the response variable that's not explained by regression. So the regression sum is the ones that are explained, the errors the ones that aren't explained. So you can say explained and then not explained, and then that makes up the total. That's basically what that's saying in English. Okay. Now, the coefficient of determination is the same thing as your SSR over your SST. Okay. So it's the variation in your observed of the response variable explained by regression. All right. So we can find, if I give you SSR and SST, it's very easy for you to find r squared. Now, used to, you would have to find SSR and SST. Very long process, but the enhancement of computers has made this a lot more manageable and a lot easier in terms that instead of being a calculation kind of section, this is turned into an analysis kind of section, to where I just want you to be able to explain to me what the data means. Is it useful, or is the equation useful or not, based on the coefficient of determination. So you're doing more of analyzing rather than working out. You're going to not have to do that so much now. Regression identity. This is just an identity to help relate all three of these. So if I give you two of the three, you can solve for the other. So why would this be important to us? Well, if we're given the total sum and we're given the error, you can find your SSR, and you could use the SST that you're given and the SSR you found to find the coefficient of determination. So it allows you to solve for a variable so that you can ultimately get the coefficient of determination. So make sure that regression identity, make sure you use it. You're going to see some problems on homework with it. Be able to plug into it. Be able to plug into the coefficient of determination R squared equals SSR over SST down here at the bottom. Now we're not going to spend much more time on this because our majority of our work is going to be done by taking the data, plugging it in the calculator, and getting the coefficient of determination that way, so that we can then determine whether or not the equation is useful for the data that we have. Okay, so here's what I mean. If you remember from section 4.2, this is the regression equation that we found, and this is the t-chart that we had. Now, let's review how to do this in our calculator. So, here's our calculator, and I know that's pretty fancy, so this is something new for us. So, let's review what we need to do here. We need to go to Stat and Edit, so you can mash Enter. And you see your L1 and L2 here. So our X values are going to be our L1, our Y values are going to be our L2. So type them in. So 5, 4, 6, and there are 3 5s in there. There are 2 more 6s, a 2, and 2 7s. Alright, so that's our X values. Now mash your right arrow key, and that takes you up so you can do the Y values. So go ahead and punch that out. And as you're typing this in, just remember that make sure you type it in correctly so you don't make any careless errors with this. 98, 66, 95, then we've got 169, 70, and 48. Alright, so we have our data typed in. Now, how do we find this regression equation that I have up here? Well, if you remember, first of all, go to Second, Catalog, and then mash the D button right here. It's the X to the negative first button. And scroll down till you see Diagnostic On. Mash Enter. And enter again. It's going to say Done. That means our diagnostic is on. Okay? Now you can go back to Stat, over to Calc, and number 4, which is the line of regression. Now, before you mash Enter, we want L1 and L2, if you remember. So second, number 1 gives us an L1, comma, second, number 2 gives us an L2. And when you mash Enter, here's your data. Now notice, we were given A. It gives us your A, your B, your R squared, and your R. Now in section 4.4 we'll talk about what R is. But right now you can see A and B as we translated it to the equation. Okay, so for instance, as it's translated in terms of the equation here, you can see that here, this right here would be, now this is acting funny with me, so hold on. This right here would be our B, and this other would be our A. Okay, so we have our B right here, and it's acting funny. Excuse me. We have our B, and this right here would be our A. Okay, so now notice, look at your calculator. Look at your calculator, and what we're trying to find out how useful this this regression equation is. Now, I've just shown you, we reviewed just now how to find it. This is how you find your regression equation, but you're given a couple of more things. You're given R squared, you're given R. Now, if you look at R squared is 0.85. Now, what did we say? The closer to 0, it was not very useful. The closer to 1, it was very useful. So how useful is this equation? Well, 0.85 is pretty close to 1. So this is going to be a very useful equation. Okay, this is going to be one that you can get some pretty reliable data out of, and that you can make some pretty reliable trend suggestions on. Okay, so this is how I'm going to want you to take the t-chart you're given, plug it in, and this is how we're going to want you to get your coefficient determination so that you can interpret whether or not this is useful. That's the goal, be able to interpret, not necessarily calculation, but to be able to interpret whether or not this particular regression equation is useful. Now hopefully that's pretty easy to. Hopefully you've got your calculator working at home and you're good to go with this. Remember, section 4.2, I played a video of how to do this. You can also find some helps on my math lab under the tools for success. You've got some instructional videos on your graphing calculator there. So hopefully you're learning how to do this, and hopefully this will be pretty easy for you since we're using the calculator to help find it. You've just got to make a good judgment call on whether or not it's useful. You've got to learn what to do with it. So hopefully this helps you with that, and if you have any questions, please please do not hesitate to ask your instructor. Have a great day.